Bismillahirrahmanirrahim. Assalamu alaikum everyone. Welcome to our YouTube channel. My name is Shoaib Ahmed. Today I am going to discuss about past paper of MEPCO test Part-6 for junior engineer position which were conducted by NTS in 2015. Now I am going to discuss about question number 51. In cumulatively compound DC motor, shunt and series field winding, there's a four option. The correct answer is C. Add up to each other. Compound DC motor is a compound of both series and shunt motor. It is consists of a series field coil which is connected in series with armature field winding and shunt field coil winding. As you see from the figure, shunt field coil winding which is connected in parallel with the armature field winding. Presence of both field winding, series field winding and shunt field winding gave this motor the name of compound DC motor. A compound DC motor can be further subdivided into two types known as cumulative compound motor and second is differential compound motor. In cumulative compound motor, the flux produced by shunt coil winding is in line with the flux produced by the series field winding. Therefore, both the flux and up to provide more flux. In contrast to the cumulative compound motor, in the case of a differential compound motor, the flux produced in shunt coil is in opposite direction to the flux produced in series coil winding, resulting in total flux equal to the difference of the both fluxes. A compound DC motor has two field windings. These are called the series winding and the shunt winding. The effect of one winding can be cancelled by the other. Cumulative compound DC motor, if the two field winding, series and shunt, are wound in such a way that the flux is produced by them aid or assist each other. In differential compound DC motor, if the two field windings, series and shunt, are wounded in such a way that the flux is produced by them always try to oppose and try to cancel each other. In the case of a cumulative compound motor, both the shunt and series field will act simultaneously and assist each other. This results in more flux for any given current. More flux will mean more torque and reduce speed as compared to the shunt DC motor. Now we come to the question number 52. Primary and secondary winding of ordinary two winding transformer always have. There's a four option. The correct answer is C, a common magnetic circuit. You can see this is a two winding transfer, the input primary and the output secondary. The primary winding is the winding that the supply voltage is applied to, and the secondary winding is the winding to the load is applied. This is irrespective of the voltage levels. In a step-down transformer, the primary voltage will be higher than the secondary voltage, higher input than output voltage. In a step-up transformer, the primary voltage will be lower than the secondary voltage, lower input than output voltage. Now we come to the question number 53. In a transformer, the leakage flux of each winding is proportional to the current in that winding because there is a four option. The correct answer is B. Leakage path do not saturate. You can see from the transformer, this is the primary winding, this is the secondary winding, this is core of the transformer which is connected between two windings. This is the main flux and this is the leakage flux. Leakage flux is essentially a wastage. When voltage is applied, magnetic flux is produced in the primary winding. This magnetic flux travels through the core of transformer and induce an EMF in the secondary winding. The leakage flux is those which do not travel through the core all along but are primarily lost in air adjacent to the winding. Now we come to the question number 54. Every amplifier system is dash to achieve linearity. There is a four option. The correct answer is A. So what is the purpose of preamplifier? The purpose of a preamplifier is to amplify low-level signals to line level. Class A amplifier has the highest linearity and the lowest distortion. The amplifying element is always conducting and close to the linear portion of its transconductance curve. To achieve high linearity, and again the output stage of a class A amplifier is biased on conducting all the time. Then for an amplifier to be classified as a class A, the zero signal ideal current in the output stage must be equal to or greater than the maximum load current, usually a loudspeaker, required to produce the largest output signal. Now we come to the question number 55. Class A amplifier, the conduction angle is, there is a four option. The correct answer is B, 360 degree. What is conduction angle of class A amplifier? Class A amplifier is a high gain amplifier with high linearity. In case of class A amplifier, the conduction angle is 360 degree. You can see this is a class A amplifier. This is conduction angle which is complete 360 degree. As we stated above, the 360 degree conduction angle means the amplifier device remains active for the entire time and use complete input signal. Now we come to the question number 56. For current amplification, we mostly use, there are the four options. The correct answer is C. Now you can see the different amplifiers, the types of amplifiers are mentioned here, and different modes are there: common base, common emitter, and common collector, and different formulas are mentioned here. So now I'm showing you the common collector amplifier figure. This is the figure of common collector amplifier. So what is common collector amplifier used for? The common collector or grounded collector configuration is generally used where a high impedance input source needed to be connected to a low impedance output load requiring a high current gain. Now we come to the question number 57. Which circuit produces output without any external source? There are four options. The correct answer is A, oscillator. Oscillators are circuits that produce an output waveform without an external signal source. The key to oscillators operation is positive feedback. What is the difference between oscillators and amplifiers? Amplifier is an electronic circuit which gives output as the amplified form of input, and oscillators is an electronic circuit which gives output without application of input. The amplifier does not generate any periodic signal. This is the major difference between oscillators and amplifiers. Now we come to the question number 58. Common emitters is used for amplification of. There's a four option. The correct answer is C, power. The main application of common emitter amplifiers are used in radio frequency transceivers circuits, used in oscillator circuits, used in low noise amplifiers. Now we come to the question number 59. Power P is to be transmitted by our headlines, our length L, for same power loss and same voltage between conductor and earth. The least conductor material required is in. There is a four option. The correct answer is A, two-wire DC system. Now we come to the question number 60. Normally use dash alternating power for transmission. The correct answer is B, three-phase. Three-phase power supplies are more efficient. A three-phase power supply can transmit 3 times as much power as a single-phase power supply, while only needing one additional wire, that is 3 wire instead of 2. Thus, three-phase power supplies, whether they have 3 wires or 4, use less conductor material to transmit a set amount of electrical power than do single-phase power supplies. I have compiled all the MCQs in one PDF file and its link is given in descriptions. You can easily download. Thanks for watching video. Please like and subscribe to our YouTube channel and click the bell icon to get new video updates.